For this video, we're going to take a look at how to graph linear equations. One of the first things you need to do is set up a coordinate system and be familiar with how that works. So what we have first is called the coordinate plane. You have two axes. You have a horizontal one, which is the x-axis, and the vertical one, which is the y-axis. And you'll notice this actually divides the plane up into four different quadrants, 1, 2, 3, and 4. All the numbers from the place where the two axes cross is going to be positive to the right and negative to the left, or positive going up and negative going down. The place where the two axes cross is called the origin, and usually you'll start counting from that point. To figure out where the location is on your coordinate system, you're going to use an ordered pair. They'll be set up in parentheses, where you'll use the first value for the x, or horizontal distance, and the second value will be the y, or the vertical distance. So if I put in a value for this, for my ordered pair, such as 2, -3, it's telling me that the first value I want to do, starting from the origin, is go 2 units that are positive. So from the origin, I want to go over 2 to the right. And then the -3 is the y value telling you how many you want to go up or down. So after I've gone 2 units to the right, I'll end up going down 3 units to put my point in. So that's going to give you that ordered pair of 2, -3. The other thing that is going to be important when you're working with a coordinate system is talking about where things cross the axes. And that's called your intercepts, where you're going to cross the axis. So what we're going to do is take a look at some equations and talk about how to find intercepts for them. What we want to look at first is the standard equation of a line. The standard form is ax plus by equals c, where the a, b, and c are all going to be number terms. So we've given you an example. You'll notice we have 3x minus 2y equals 12. Both of your variables, the x and the y, are going to be used in these equations because you're going to have it on a coordinate plane where you need both the horizontal and the vertical distance. The other thing to note is that both of these have as a power on the variables a power of 1. So that will be consistent for any kinds of equations for lines. So let's take this equation that's in standard form and find the intercepts. Finding intercepts are easiest when you have an equation in standard form. In order to locate the intercept, I want to plug in a value of 0 for one of the variables. So I'm going to multiply 3 times 0 minus 2y equals 12. And that's going to eliminate one of my variables. So the x's are going to be gone, and I only have the variable y to solve for. So solving for y, if I divide both sides by -2, I get a value of y equals -6. This is going to be considered your y-intercept, or where you're going to cross the y-axis. Sometimes you'll see it written as y equals -6, and sometimes you'll see it written as an ordered pair. X was 0, y is -6, and that means when I go to put it on my graph, that's the ordered pair I'll be using. If you want to go ahead and find the other intercept, where it's going to cross the x-axis, you'll do the same thing, but this time you're going to go ahead and plug in 0 for y. So I'd solve my equation by first sticking in 0 for the y value. And that's going to eliminate one of the variables, the y variable. So I end up with 3x equals 12. And dividing both sides by 3, the x-intercept is going to be 4. Now again, they may use the value x equals 4 to describe the intercept, or they could write it as an ordered pair. The x value is 4, and we plugged in 0 for the value for y. So 4, 0 is the ordered pair that you'll be using for your intercept point. Let's go ahead and put these intercepts on our graph. So we had the intercept 0, -6. So I'm going over 0 from my origin, and -6 was my y value. 1, 2, 3, 4, 5, 6. So that y-intercept, where I cross on the y-axis, which is your vertical one, is going to be down at -6. For your x-intercept, it was 4, 0. So 1, 2, 3, 4. I'll be crossing the x-axis at the location 4, 0. So you can always put in a graph of a line by connecting any 2 points. So finding the intercept points are 2 easy ways to get 2 values to use to go ahead and graph your line. Another important point when you're working with lines is talking about the slope. So when we have a line, what is a slope? And then we want to look at how you can find it. Typically when you're working with a line, you can think of slope as the steepness for your graph. There's 2 different things that can happen. You either look at the steepness and think about the line. If it looks like it's going uphill, it's going to have a positive slope. And the one that we just did had a positive slope. It looks like it was going uphill. Or if you have a graph for a line that looks like it's going downhill, then it's going to have a negative slope. Well, we want to talk about how you can find the slope. There are some formulas that you can use. But typically, when people think about slope, they remember the idea of rise over run. Rise being the value you have in the vertical direction, and run being your value you have in the horizontal direction. You can also think of it as the change in the y value divided by the change in the x value. We had 2 values that we used that were going to be intercept points. And I could look at that distance to see what my slope is for these points. So if we go back to our graph, and we look at those points that we had, here's one point that I started at. Here's the next point that I ended up at. I can take a look at the change that I had in the y direction. This change to go from here to here, we had to move 6 units up. And this change to go from here to here, we needed to move 4 units over. So I went up +6 and to the right +4 to get from one point to the next point. If I want to set this up and use it for my slope, then the values I'm going to have is the change that I had in the y direction, 6, over the change I have in the x direction, 4. Usually they'll go ahead and reduce any fractions that you have so that they're in lowest terms. So I would actually have a slope of 3/2. This is the one time that you really do want to have a fraction. I know most of the time you don't like working with fractions. But by having it in a fraction form, this is actually giving you a lot of information, because that fraction, that top number, is telling you how much you changed in the y direction, the rise, and the bottom number is telling you how much you changed in the x direction, the run. So we've taken a look at how to find the slope. Let's talk about what happens with some slopes for lines that may not be either going uphill or downhill. Let's say you have a line and it's a horizontal line. Anytime you're working with a horizontal line, it looks like it does not have any steepness at all. So the value that you're going to have when you're looking at this line, it's going to be flat for a horizontal line. Its slope would be considered 0. And if you want to have an equation for one of these lines, if you're working with a horizontal line, it's always just going to have a height that will be up or down as a horizontal line in some direction. So your equation will be y equals some number. Vertical lines also are a little bit unique. For a vertical line, you're going straight up and down. That steepness looks like it is infinite. You can't determine that steepness. So usually the value for the slope for this is considered undefined. Because you're working with a vertical line, it's just going to be straight up and down over, at some point, positive or negative on your graph. So the equation for a vertical line is x equals a number. These two don't fit into the regular pattern that we looked at when we talked about things that were in standard form. They don't have both the x and y value in them. Just a y value, y equals a number for a horizontal line, x equals a number for a vertical line. Another thing they may ask you about are slopes for lines that are parallel or perpendicular. When you have two parallel lines, they're going to run and never cross each other. They'll stay the same distance apart all the way through. So anytime you're asked about the slope for parallel lines, they have the same slope. Perpendicular lines are going to make a right angle. So anytime you're asked for the slope for perpendicular lines, those are going to have slopes that are negative reciprocals of each other. So this gives you a general overview of what happens with lines for slopes. We want to talk about finding a slope if instead of giving you an equation, they give you 2 points. It's going to be very similar to what we did when we looked at our graph and we looked at going from one point to the next point. If you wanted to, you could put these on a graph, put the point -6, 1 and the point 2, 3 on your graph, and see how far you have to go from one to get to the next. If I'm at -6, 1, I'll have a point here. And at 2, 3, I'll have a point here. And if I'm trying to figure out the distance to go from one point to the next, I had a total of 6 plus 2 more, or 8 units that it looks like we had for our run. And for the rise, we went from 1 unit up to 3 units, so it looks like we had a rise of 2. If I'm setting up my slope, where I'm looking at the rise over the run, I have a slope of 2/8, or 1/4. If you don't want to graph it to look at what your slope is, you can also do it algebraically. Take the difference in the y values, because I'm looking at the change in the y values on top, and compare that to the change in the x values. So for my x values, I have 2 and -6. Make sure you start with the same point each time. Since we started with this point, 3 minus 1, we'll start again with this point. 2 minus. Be careful if you have negative numbers. That's where you need to watch out so you don't drop any signs. So I'm working with 2 minus -6 in the denominator. Notice this gives me 2/8. Same thing we had when we looked at the graph for the picture, which is equal to 1/4. The last thing we want to talk about for equations of lines is a different format that you might see. We already looked at the form which was considered a standard form, and now we're going to look at a slope-intercept form. An equation of a line that's in a slope-intercept form still has the variables x and y, but you'll notice that this format is a little different. It's set up y equals, and everything else is over on the right-hand side. The 2 values that you notice in the equation, mx and b, stand for particular things that are going to be helpful for your equation. M represents the slope, which we just discussed. B represents the y-intercept, which we talked about at the beginning. If you have an equation that's in this format, it's very easy to go right from the equation to the graph, because you can see where you're going to cross the y-axis, and you can use the idea of the slope, the rise over the run, to get another point on the line. Here's the equation we used when we did it with intercepts. So let's take the same equation, and let's see if we can change it from the standard form into the slope-intercept form. I'm going to want to get y by itself and move everything else to the other side. So I'm going to start by subtracting 3x from both sides, and then dividing each term by -2. I'll end up with y equals. I have negative 3 over negative 2. And usually if you have a negative divided by a negative, they'll go ahead and write it as 3/2. Get rid of the negative signs. Minus 6. Let's go ahead and graph this using this information. I want to start by putting in the y-intercept first. So for my y-intercept at negative 6, I'm going to go down 6 places. 2, 3, 4, 5, 6. And that gives me a starting point. This is different from your regular ordered pairs. You aren't going to necessarily start at the origin like you usually do. We have 1 point on our line, and we're going to use the slope to get our next point. For using the slope, start at that y-intercept. The top number tells you how much to go up or down for the rise. The bottom number tells you how many to go right or left for the run. So from here, I'm going to go up 3 to the right 2. That gives me another point on my line. And I could keep using this same idea to get more points on my graph. I could go up 3 again, and then to the right 2. Each time, it's just giving me more points that are going to be on that line. You only need 2 to get your line. But I wanted to go ahead and use it twice to show you what's happening. Notice when we did do it twice, here was our first point, here's our second point. These are the same intercept points we had when we first graphed it. Y-intercept at negative 6 and your x-intercept at 4. So you will get the same graph regardless of whether you graph it using those intercept points or graphing it using the sloped intercept form. Hopefully you have a better feel for how graphing linear equations works.